trailing zeros. Trailing zeros. I will start again from the basics. Trailing zeros means number of zeros at the end. Number of zeros at the end. Or in other words, it is nothing but the highest power of 10 power k. Highest power of 10 power k. For example, 10, 20, 30 and so on up to 90. This will have number of trailing zeros 1. Number of trailing zeros 1. Or it is nothing but the highest power of 10 which is 1. All got 1 0 at the end. 10, 20, 30 till 90. All got 1 0 at the end. Suppose if it is 100, 200 and so on up to 900. This has got number of trailing zeros or number of zeros at the end is nothing but 2, which is nothing but the highest power of 10 square. 10 square, it is nothing but 10 power 2. So highest power is 2. Similarly, 1000, 2000 and so on up to 9000. Last 3 digits is nothing but 3 zeros. Number of trailing zeros is 3, which is nothing but 10 power 3. Which is nothing but 10 power 3. Number of zeros at the end. Number of zeros at the end is nothing but trailing zeros. How we get number of zeros at the end? It is nothing but highest power of 10 power k. It is nothing but highest power of 10 power k. One example. Example 1. Extremely important concept, sir. Find the highest power for. Find the, or instead of highest power, we'll do number of trailing zeros for. Number of zeros at find the number of trailing zeros for. Highest power of 10 power. Find the number of trailing zeros for. One example. First question. Example 10 power 38. Extremely 10 power 38. 10 power 1 has got 1 0 at the end. 10 power 2 got 2 zeros at the end. 10 power 38 got 38 zeros at the end. 38 zeros at the end. 38 zeros at the end. Second one. 2 power 37 into 5 power 12. 2 power 37 into 5 power 12. 10 power 1 has got 1 0 at the end. Where are we? Second question. Please write down, sir. Find the number of trailing zeros. Number of trailing zeros for. Few more questions which we will solve. 2 power 37 into 5 power 16. Find the number of trailing zeros for 2 power 37 into 5 power 16. These is nothing but 2 into 5 power 16 into 2 power 21. These 2 power 21 into 10 power 16. 10 power 16 will have 16 zeros at the end. All the numbers will have 10 power 16 will have zeros at the end. 10 power 1 will have 1 0 at the end. 10 power 2 will have 2 zeros at the end. So answer for this question is there are 16 zeros at the end. 16 zeros at the end. Another question. 3 power 13 into 5 power 7 into 7 power 2. Number of trailing zeros. Number of trailing zeros. Number of trailing zeros. Number of trailing zeros is nothing but the highest power of 10 power k. To get 10 power k, we should get 2 power k and 5 power k. There should be a combination of 2 and 5. There should be a combination of 2 and 5. Only 5 combination is there. So answer is, there are no trailing zeros. There are no trailing zeros. I hope the concept is clear. There are no trailing zeros. To get the highest power of 10, we should get highest power of 2 and 5. 2 is not there in the second question. To get 10, we should take a minimum power of 2 and 5. To get 100, 2 square and 5 square. To get 1000, 2 cube and 5 cube. So answer is, there are no trailing zeros. Why? Because to get a trailing zero, we should get a combination of 2 and 5. Second question. I hope it is clear. Third question. Keep writing it, sir. Third question. Third question. Then we will do some good quality problems. Find the number of trailing zeros for. Find the number of trailing zeros for. Find the number of trailing zeros for. 15 factorial, 23 factorial, 58 factorial, 58 factorial, 15 factorial, 23 factorial, 58 factorial. Number of trailing zeros is nothing but highest power of 10. Number of trailing zeros is nothing but highest power of 10. 10 power k is 2 power k into 5 power k. Very, very beautiful example, because most of the students were taught by the teachers that number of zeros at the end is always highest power of 5, which in today's example I am going to prove it that it is not always true. Listen carefully. So 15 is nothing but 2 7s are, 2 3s are, 2 1s are. So 15 factorial is 2 power 11. 15 for 3 is 5 power 3 into k. So these is nothing but 2 into 5 power 3, 2 power 8 into k. So answer for this question is 3. First one answer is 3, which is nothing but the highest power of 5, which is nothing but the highest power of 5. Second question, 23 factorial, 23 divided by 2, 2 11s are, 2 5s are, 2 2s are and 2 1s are. 23 factorial is 11 plus 5 16, 18, 19. So 2 power 19 into 5 is nothing but 5 4s are 20, 5 power 4 into remaining prime bases. So it is 2 into 5 power 4 into 2 power 15 into k. 10 power 1 will have 1 0 at the end. 10 power 2 will have 2 zeros at the end. 10 power 4 will have 4 zeros at the end. Praveen, ఇది charging bettese. Answer is 4. Second one, I hope it is clear. Slowly we will increase the level of difficulty. Third one. First one clear, second one clear. Just take the powers of 2 and 5. Just take the powers of 2 and 5. Just take the powers of 2 and 5. Third one. Try to solve the third one similarly. After this problem, some very, very good problems we are going to discuss. Very, very good problems we are going to discuss. Extremely important problems which we are going to discuss. Third one is a very easy question. Then I will draw an important conclusion. Third one, 58 factorial. 58 factorial. So these is nothing but 58 factorial. Power of 2 is 2 29s are 58, 2 14s are, 2 7s are, 2 3s are, 2 1s are. So 58 factorial is nothing but 29 plus 14, 43, 50, 53, 54. 2 power 54 into 5 will become 5 11s are, 5 2s are. 2 plus 11 plus 2 13, 5 power 13 into k. So this is nothing but 2 into 5 power 13 into 2 power 41 into k. Number of zeros at the end for the third question is 13. Number of zeros at the end. The third question is 13. First, second and third. It is very easy questions. They are all very easy questions. Now I will increase the level of difficulty. Now if you observe key point 1. Key point 1. Please observe this example. Key point 1. Suppose 70 factorial number of trailing zeros. Number of trailing zeros. If you observe this example, 70 factorial. 70, what is the power of 2 35s are, 2 17s are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. How much we got? 5 14s are, 5 2s are. So 70 factorial is nothing but, if I add all these values, 7, 15, 32, 67, 2 power 67 into 5 power 16 into k. So power of 5 is very small compared to power of 2. So what I did is 2 into 5 power 16 into 2 power 61 into k I did it. So answer I got 16. What is important to me here is power of 5 is very small compared to power of 2. So automatically I took power of 5. Can I write like this? 70, first I divided by 5. 5 14s are 70. Remainder, forget about it. Then I divided 70 by 5. Then I divided 70 by 5 square. Am I right? 70 divided by 25. 25 2s are. Then I divided 70 by 125. From this, all this is 0. All this is 0. So it is nothing but 14 plus 2. Remaining all are zeros. So it is 16. Instead of doing it like this, I am doing it like this. I am doing it like this. So whatever I got is nothing but the highest power 5. Am I right? Highest power for 5. So first I am dividing, if there is a factorial number is there, first I am dividing by 5, then I am dividing by 5 square, then I am dividing it by 5 cube, and the process continues. Once you got 0, then all the numbers from that 0 will be 0. Why? What is this bracket? Bracket is, I am eliminating the remainder. 70 by 5, 14 and remainder 0. I will just write the integer. 70 by 25, 2 point something, so it is 2. 70 by 125, it is 0 point something, it is 0. 14 plus 2 is 16. Am I right? So the number of zeros at the end. Number of zeros at the end for factorial problems only. Number of zeros at the end for factorial problems only is nothing but the, not even the highest power of 10, but the highest power of 5. Please write down in the second important slide, then we will do a very important conclusion. Please write down this one. Right? Power of 2 is very high compared to power of 5. So it is equivalent to taking the power of 5 only. It is equivalent to taking the power of 5 only. Please write down number of zeros at the end. Number of zeros at the end for n factorial. For n factorial is nothing but the highest power of, is nothing but the highest power of 10. In turn it is equivalent to the highest power of 5. Power of 5 is enough. Power of 2's, the value will be right little high. Highest power of 5. So what am I doing? First I am dividing it by 5. Whatever value is there, that I will write it. Then I am dividing it by 5 square. Then I am dividing it by 5 cube. Then I am dividing it by 5 power 4. These values, after some time, the value will come out to be 0, 0, 0 and anything. Can I say this is a right? This will stop at a particular point of a time. For example, 100 will stop at 100 by 5, 100 by 25. This is a finite series. 100 by 25. Suppose if it is 200, this will stop at 200 by 5. Next is 200 by 5 square. Next is 200 by 5 cube. Next is 200 by 5 cube. Am I right? These values will stop at a particular finite value. After that, everything will be 0. Can I say finite value? This will stop at a particular finite value is always less than infinite value. N by 5, n by 5 square, n by 5 cube, and so on up to infinite. Can I say 1 plus 2 plus 3 is always less than 1 plus 2 plus 3 till infinite? Am I right? So the series will go up to, if it is infinite, so that finite series is always less than the infinite series. X is less than n by 5, which is 1 plus 1 by 5, 1 plus 1 by 5 square, and so on up to infinite. X is less than n by 5. This is nothing but 5 by 4. How you got? A by 1 minus 1 by r. This series is a GP series. Sum of infinite series in GP series is A by 1 minus r. So this is nothing but x is less than 4. That means n should be greater than 4x. Please make a note of it. What is the relationship between the highest power of 5 and the number for which factorial is added? So the relationship is n is greater than 4x. I will tell its importance. N is greater than 4x. Again I am repeating. Suppose a number is there for which factorial we have to do. That is n factorial. Right? We have to find out the highest power of 10. Highest power of 10. Highest power of 10, instead of finding the highest power of 10, it is equivalent to finding the highest power of 5 only for factorial based problems. If it is 100, 100 by 5, 100 by 5 square, 100 by 5 is 20, 100 by 25 is 4, remaining all 100 by 5 cube, 100 by 5 power 4, everything will be 0. So this is a finite series. The value of this series will stop at a point depending upon the value of n. Suppose if the value of n is 200, it will stop at 200 by 125. If the value of n is 1000, it will stop at n by 5 power 4. Depending upon the value of n, that series will stop. Can I say that 1 plus 2 plus 3 is less than 1 plus 2 plus 3 till infinite? Finite series is always less than infinite series. So x is less than n by 5, n by 5 square, n by 5 cube, and so on up to infinite. X is less than n by 5. 1 plus 1 by 5 plus 1 by 5 square till infinite. N by 5. This series is a infinite series. So answer is a by 1 minus r. 1 by 1 minus 1 by 5. If I solve it, I will get n is greater than 4x. I will get n is greater than 4x. Write down this beautiful conclusion. Beautiful conclusion. I will tell its application right now itself, then you will understand it clearly. I hope it is clear. So one important conclusion is n is greater than 4x. N is greater than 4s. N is the number, right, for which factorial is present. For which factorial is present. N is the number for which factorial is present. X is the number of zeros at the end. X is the number of zeros at the end. X is the number of zeros at the end. Example, n factorial ends with 12 zeros. How many values n can take? How many values n can take? n factorial ends with 12 zeros. How many values n can take? So how to solve this question? N is greater than, number of zeros at the end is 12. N is greater than 4x. N is greater than 4 into 12. N is greater than 48. So by this we came to know that what is the value of n? N value should be greater than 48. What is the multiple of 5? Just greater than 48, 50. 50, what will be the number of zeros? 5 tens are 50, 5 twos are 10. What is 10 plus 2? 10 plus 2 is nothing but 12 zeros at the end. I got 12 zeros. So 50 will have 12 zeros at the end. 51 will have 12 zeros at the end. 52 will have, 53 has got, and 54 has got. 50, 51, 52, 53, 54. Because if I take 55, 5 11s are 55, 5 2s are 10. 11 plus 2 is 13. I want only 12 zeros at the end. I want only 12 zeros at the end. So there are 5 values which will have 12 zeros at the end. I hope the concept is clear. Very beautiful question. Generally in our textbook, only the number of zeros at the end we will find it out. If the number of zeros at the end is given, we can also find the number. We can also find the number. N factorial ends with 12 zeros. How many values n can take? N is greater than 4x. N is greater than 48. What is the multiple of 5 greater than 48? 50. 5 tens are 50, 5 twos are 10. 10 plus 2 is 12. So if 50 has got 12 zeros at the end, till the next multiple of 5, I will get the answer. 50, 51, 52, 53, 54. I hope it is clear. 2 more examples so that this concept is extremely clear to you. First one, I hope it is clear. Second one, please write down. Second one. Second question. N factorial ends with 22 zeros. How many values n can take? How many values n can take? N factorial ends with 22 zeros. How many values n can take? So the answer for this question is n is greater than 4x. N is greater than 4 into 22. N is greater than 88. What is the lowest multiple of 5? Just greater than 88, 90. Let us see. These nothing but 5 18s are 90. 5 3s are 15. 5 3s are 15. 18 plus 3. How much I got? 21. How much I require? 22 I require. Let us check with the next multiple of 5. 5 19s are 95. 5 3s are 15. What is 19 plus 3? 22 I got. If this is not satisfying, go to the next number. Go to the next number. 19 plus 3 is 22. So answer is 95 will satisfy. 96, 97, 98 and 99. Totally how many values will satisfy? 5 values will satisfy. 5 values will satisfy. I hope if not the lowest multiple of 5, after 88 go to the next value. What is the value of n after 88? 90. 90 is giving you 5 18s are 90, 5 3s are 15. 18 plus 3 is 21, but I want 22. So if I take 95, 5 19s are 95, 5 3s are 15. 19 plus 3 is 22. Write down one more question. Write down one more question. Please put a star mark on this question. Very important observation which we are going to do it. Please write down. Please write down. N factorial. N factorial. Third example. N factorial ends with n factorial ends with 17 zeros. How many values n can take? How many values n can take? N factorial ends with 17 zeros. How many values n can take? So n is greater than 4 into 17. n is greater than 68. What is the multiple of 5 just greater than 68? 70. 70 is nothing but 5 14s are and 5 2s are. 14 plus 2 is 16 zeros. I want 17 zeros. Take the next multiple of 5. 5 15s are 75. 5 3s are 15. 15 plus 3 is 18 zeros. 16 zeros jump to 18 zeros. 17 zeros I am not finding it. So no value of n exists. Answer is no value of n exists. I hope the idea is clear. No value of n exists. It cannot have 17 zeros at the end. Sir, why it is happening directly from 16 it is jumping to 18? Why? Because 75 is nothing but a multiple of 25. 25 is 5 square. Not only 1 power of 5, there will be jump of 2 powers of 5. There will be jump of 2 powers of 5. So it is not always that you will get the answer depending upon the question, right? Sometimes you might get the answer, sometimes you might not get the answer. N factorial ends with 17 zeros. N is greater than 4x. N is greater than 68, 70. 5 14s are, 5 2s are. 14 plus 2 is 16. It is 15 plus 3 is 18. 16 became 18. So 17 zeros will not come in any of the factorial. Answer is no value of n exists satisfying this equation. I hope it is clear. N is greater than 4x. N is greater than 4x. N is greater than 4x. Extremely important conclusion to correlate factorial with number of zeros at the end. To correlate factorial with number of zeros at the end, the relationship is n is greater than 4x. N is greater than 4x. I hope the idea is clear. Now, another idea. Please write down. Another idea. Key point 2. Key point 2. Suppose 2 in base system 10. In a base system, 2 is 1 0 because it is 2 ones are 2, remainder 0. 4 in base system 10. 4 is 2 square. In a base system 10 is 1 0 in base system 2. 4 in base system 2. 2 2s are 4, remainder 0. 2 ones are 2, remainder 0. 1 0. 8 in base system 10. It is nothing but 1 000 in base system 2. So 8 is nothing but 2 4s are 8. 2 2s are 4. Remainder 0. 2 2s are 0. 2 1s are 2. It is 1 000. 1 000. Very, very important key point. If there is 1 0 at the end, it is nothing but the highest power of 2 in base system 10. If there are 2 zeros at the end, this is nothing but the highest power of 2, which is 2 at the end. If there are 3 zeros at the end, this is nothing but the highest power of 2, which is 3 at the end. Very, very important point. Number of zeros at the end. Number of zeros at the end in base system K. Number of zeros at the end in base system K. It is nothing but highest power of K. It is nothing but highest power of K in a base system 10. Please make a note of it. Please make a note of it. Number of zeros at the end in base system K. Number of zeros at the end in a base system. In a base system 2 is nothing but the highest power of 2 in base system 10. So 4 in base system 10 is 2 zeros at the end. 2 at the end is nothing but the power of 2. 3 zeros at the end is nothing but the power of 2 in base system 10. Number of zeros at the end in base system K is nothing but highest power of K in base system 10. Number of zeros at the end, 3 zeros are there. It is nothing but the power of 2, which is 3. 2 zeros at the end, it is nothing but the power of 2. I hope the idea is clear. Number of zeros at the end in base system k is equivalent to highest power of k in base system 10. Number of zeros at the end in base system k is highest power of k in base system 10. Please write down the questions. Question: 37 factorial in base system 10. In base system 7, how many trailing zeros are there? 37 factorial when converted into base system 7, how many zeros it will give? How many zeros it will give? 37. This question in a statement is 37 factorial when converted in base system 7. When converted in base system 7, when converted in base system 7, has dash number of trailing zeros, has dash number of trailing zeros. 37 factorial when converted in base system 7 has a dash number of trailing zeros. Just now we discussed number of trailing zeros in base system 7 is nothing but the highest power of 7 in 37 factorial. So this is nothing but 7 5s are 35. Answer is 5 zeros at the end. Just a twister in the question. You might think that the question is a difficult question. It is not a difficult question. It's an easy question. 37 factorial when converted in base system 7 has a dash number of zeros. Any number if you converted to base system k, number of zeros at the end is nothing but the highest power of base system for that number. So it is nothing but highest power of 7 in 37 factorial. So 37 factorial highest power of 7 is 7 5s are 35. Answer is 5 trailing zeros. Answer is 5 trailing zeros. 3 more questions, the idea will be extremely clear to you. Idea will be extremely clear to you. 70 factorial in a base system 10. If I convert into base system 9, how many number of trailing zeros are present? How many number of trailing zeros are present? Number of trailing zeros. This is nothing but highest power of 9. Highest power of 9 in 70 factorial. 9 is nothing but 3 square. So 70 factorial is 3 23s are, 3 7s are, 3 2s are. So 70 factorial is given by 23 plus 7 30, 30 plus 2 32. 3 power 32 into some other prime bases. So it is 3 square power 16 into some other prime bases. Answer is number of trailing zeros is nothing but 16. I hope it is clear. This is a straightforward question. The question can be twisted like this. 70 factorial in base system 10. In base system 9 will have how many zeros at the end? Number of zeros at the end is nothing but the highest power of that number for that factorial. Highest power of 9 in 70 factorial. 9 is 3 square. So 9 is a composite number. Do it for 3. 3 23s are, 3 7s are, 3 2s are, which is 3 power 32, which is nothing but 3 square power 16 into k. 9 power 16. So answer for this question is 16. I hope the idea is clear. One more question. (123 factorial in base system 10. If I do it in base system 21, which is 21, how many number of trailing zeros are present? How many number of trailing zeros are present for this number? This is nothing but number of zeros at the end. Number of zeros at the end. Number of zeros at the end for base system K is highest power of that base system. So this is nothing but highest power of 21 in 123 factorial. 21 is nothing but 3 into say 7. So 123. 3 will be 341. This will be 313. These 3 4s are and it is 1s are. Similarly for 7. 7 1s are 53. 7 7s are. It is 7 2s are. So 123 factorial is nothing but, if I add all these values, 41 plus 13, 54, 58, 59. So 3 power 59 into 7 power 19 into K. I want for 21, 3 into 7 power 19 into 3 power 40 into K. Number of zeros at the end, which is nothing but 19. Number of zeros at the end, which is nothing but 19. I hope it is clear. Praveen, mobile disko. Right, now you can ask me any doubts in this topic. Number of trailing zeros, basics are over. Now I will increase the level of difficulty. Highest power of 21. 21 is 3 into 7. Just to do it for 7, that is enough. Do it for 7, that is enough. Number of trailing zeros. Number of trailing zeros for base system K is nothing but the highest power of K in base system 10. Idea clear? Idea clear? Rambabu, nee phone ivu, din charging levu. Idea clear? Kindly reply it in the live chat. Reply it in the live chat. Any doubts till now? Number of trailing zeros is nothing but the highest power of 5 in base system 10. What if another base system is given? How to solve? Everything clear? I hope there are no echo issues. You got any technical issues? Kindly reply it in the live chat. Kindly reply it in the live chat. I hope it is clear. Now 123 factorial. Idea clear? So any doubts, please you can ask me, right? Explain 2 power 3. Priya says, explain 2 power 3 base number of trailing zeros in base system 2. Now we will take up a question, Priya, for you, right? So let me take up a question. Suppose if it is 60 factorial in a base system 10. If I translate into, she asked 8. How many number of trailing zeros are there in a base system 8? Number of trailing zeros in a base system 8. Number of trailing zeros in a base system 8. So this is nothing but, Priya, for you. This is nothing but highest power of 8 in 60 factorial. 8 is nothing but 2 cube. So 60 factorial is 2 30s are, 2 15s are, 2 7s are, 2 3s are, and 2 1s are. So 60 factorial is nothing but 45, 52, 55, 56. So this is 2 power 56 into K. I want for 2 power 3. 2 power 3 power 18 into 2 square into K. So answer for this question is 18. I hope it is clear. Everybody kindly reply it in the live chat if this concept is clear to you. Is this concept clear to you? Is this concept clear to you? I want everybody to reply it in the live chat. Then we will do some exercise problems. Exercise problems. Praveen, some exercise problems which we will solve once everybody says it is clear. Mahesh says it is clear. Anup says good. Right? Keep this charging. Kindly reply it in the live chat so that we can go ahead with problems. Any doubts? Any doubts? Highest power of 8 in 60 factorial. Idea clear, right? Now, we will solve few exercise related problems. Now see, first one. Find the number of trailing zeros for 100 factorial. For factorial based problems, number of trailing zeros is nothing but the highest power of 5. So directly divide by 5. 5 20s are and 5 4s are. 20 plus 4. Answer is nothing but 24. Answer is 24, which is nothing but number of trailing zeros. Number of trailing zeros for n factorial. For n factorial is always highest power of 5. Is always highest power of 5 in n factorial. Only for factorial based problems. Only for factorial based problems, this concept is directly applicable. Only do it for power of 5. Sometimes it will go for a toss if the factorial some changes are done. What is that one? We will see. Number of trailing zeros for 100 factorial is highest power of 5. Answer is 24. Second question. Read the question. Find the number of trailing zeros for 150 factorial plus 200 factorial. 150 factorial plus 200 factorial. Right? Now see here. 150 factorial. 200 factorial is written as 200 into 199 and so on up to 150 factorial. So 150 factorial, if I take common, these 1 plus 200 into 199 and so on. This is nothing but divisible by 5. Divisible by 5 plus 1. That means this number is not divisible by 5. This number is not divisible by 5. So highest power of 5 will not come in this number. So answer is 530s are 5 6 are 5 1s are 30 plus 6 plus 1. Answer for this question is 37. Answer for this question is 37. Priya says, sir, in previous problem we discussed the same problem. 8 in base number 10. Number of trailing zeros for base 2. It is 3. How, sir? Right? Answer is 2. I am not clear with your question, Priya. Kindly WhatsApp your question to our official number which is there on the screen. Kindly WhatsApp it so that I will understand. Prashant says, for method 2, 100 factorial, it is different. 100 factorial, it is different. It is not different. It is the same number. Sohail says, if the given prime number has base system 11 and higher, then the same process. Yes, it is the same process. Let us go back. Suppose for Sohail, it is 120 factorial in base system 10. If I convert into base system 11, so this is nothing but the highest power of 11. Highest power of 11 in base system 120. In base system 120. It is the same thing, right? Prashant, I am not clear with your statement, so I will not be able to take up your doubt. If you can specify it clearly, I will understand. Otherwise, WhatsApp. Right? WhatsApp your entire explanation. I hope the answer is 37. Now, third question. Find the number of trailing zeros for 1 followed by 4 zeros. 10 power 4, power 50 into 10 square, power 30. So, this is nothing but 10 power 200 into 10 power 60, which is nothing but 10 power 260. 10 power 1 will have 1 0 at the end. 10 square will have 2 zeros at the end. 10 power 260 will have 260 zeros at the end. 260 zeros at the end, or in other words, it will have 260 trailing zeros. It will have 260 trailing zeros. I hope the idea is clear. 10 power 4 power 50 into 10 square power 30, 10 power 200 into 10 power 60, 10 power 200 into 10 power 60 is 10 power 260. So answer is 260 zeros at the end. Another question. Slowly I am increasing the level of difficulty. Listen carefully, sir. 20 into 30 into 40 till 100. This is nothing but 10 into 2. This is 10 into 3. Next it is 10 into 4. And it goes on up to 10 into 10. 10 into 10. 10 is multiplied. From 2 to 10, there are total 9 numbers are there. 2, 3, 4, 5, 6, 7, 8, 9, 10. Total there are 9 numbers are there. So it is 10 power 9 into 2 into 3 into 4 and so on up to 10. So this will become 10 power 9 into, this is 10 factorial. This is 10 factorial. Am I right? So 10 factorial is nothing but 2 5s are 10, 2 2s are 4, 2 1s are 1. 5 plus 2 plus 1 is 8. So these is nothing but 10 power 9 into 2 power 8 into 5 square into some other prime bases. So these is nothing but 10 power 9 into 10 square into 2 into 5. 2 power 6 into k. So answer for this question is 11. Answer for this question is 11. I hope the idea is clear. Please do not say the answers in the live chat. I am not asking you to say the answer. If you got the answer, keep it with you, because there are certain questions where you will do a mistake and you will miss out why there is a mistake. You have done it because you have missed out that explanation. Kindly clear, right? Kindly clear. It is into 90 is missing, sir. Please add 90. Into 90. 90 is missing in the question. It's a typing mistake. Please add 90 to it. It is 90. In hurry, my team members might have missed it out. 90. It is into 90. Into 90. Please add it. Balaji, yes, 90 is missing. Please add it out. Right? Next one. 10 power 9 into 2 into 3 into 4 till 10. 10 power 9 into 10 factorial. Next one. Another question. Find the number of trailing zeros. Now before this question, yes, let us solve this question. See here. If n factorial ends with 13 trailing zeros, what is the possible value of n? Then we will solve the previous question, because this we did it. If n factorial ends with x zeros, if n factorial ends with x zeros, this is nothing but n is greater than 4x. We already did this condition. So this is nothing but n is greater than 52. What is the multiple of 5 just greater than 52? 5 11s are 55. 5 2s are 10. 11 plus 2 is 13. So what are all the values you will get? 55 you will get, 56, 57, 58, 59. Totally 5 values will have 13 trailing zeros. How many values n can take? 5 values n can take. 5 values n can take. 5 11s are 5 2s are 11 plus, right? 5 11s are, n is greater than 52. 11 plus 2 is 13. That is the question. This concept you should know it. N factorial ends with x zeros. So n is greater than 4x. So n is greater than 4x. Idea is clear? Next one. N factorial ends with x zeros. If n is n factorial is ending with x zeros, what is the relationship between n and x? The relationship is n is greater than 4x. N is greater than 96. What is the multiple of 5? Just greater than 96. 100. 5 20s are 5 4s are 20 plus 4 is 24. So 100 I will get, 101 I will get, 102, 103 and 104. Answer for this question is again 5 values. Right now I think it should be very clear to you how to find out the values of n. If the number of zeros at the end is given, if the number of zeros at end is given, the relationship is n is greater than 4x. Next one, another beautiful question. N factorial never ends with dash number of zeros. N factorial never ends with dash number of zeros. Suppose if it ends with 5, if it ends with 5, if it ends with 5, n is greater than 4x, 4 into 5, n is greater than 20. What is the multiple of 5 greater than 20? 25. 5 5s are 25, 5 1s are 5, 5 plus 1 is 6. It ends with 6, never ends with 6 is over. What is the next multiple of 5? 30, 5 6 are 30, 5 1s are 5. What is 6 plus 1? 7. It ends with 7 zeros. If it is 35, 5 7s are 5 1s are. What is 7 plus 1? 8. It never ends with 5 zeros. I hope the idea is clear. If I take the option number 1, assume that if it ends with 5 and check whether my assumption is right or wrong. N is greater than 4 into 5, n greater than 20. So what is the multiple of 5 greater than 20? 25. 5 5s are 5 1s are. 5 plus 1 is 6. 6 I am getting. 7 I am getting. 8 I am getting. So 5 I am not getting. So answer for this question is 5. I hope the idea is clear. Next question. N factorial ends with 20 zeros. N factorial ends with 20 zeros. 20 zeros in base 21, which is 7 into 3. Now see here, similarity. Once you get the similarity, this question is very easy for you. If n factorial ends with 15 zeros, 15 zeros in base system 10, in base system 10, 10 is 2 into 5. First I took the highest power, 5. This got n is greater than 4x. From where you got 4? 4 is 1 less than the highest factor of 10. 1 less than the highest factor of 10. Similarly, this is nothing but 21. Highest is 7. So this answer is n is greater than 6x. I hope it is clear. Beautiful conclusion, sir. If it is in a base system 10, 10 is 2 into 5. Highest is 5. So this will be n is greater than 4x. N is greater than 4x. If it is 7, it will be n is greater than 6x. N is greater than 120. What is here? I took the multiple of 5 just greater than the number. Here I will take the multiple of 7 just greater than that number. So 126. 7 1s are 7. 7 8s are 56. 7 2s are 14. What is 18 plus 2? 20. So from 126 till the next multiple I will get the answer. Till 132. 126 till 132. Answer is how many values it can take? 7 values it can take. Right? I hope the idea is clear to you. I hope the idea is you don't need to convert it. N factorial ends with 15 zeros in base system 10. In base system 10 is 2 into 5. Because it is 2 into 5, powers of 5 are smaller than the powers of 2. So what I did it? How I got these 4 by x? I did it as x is less than n by 5, n by 5 square, and so on up to infinite. That is where I did it. X is less than n by 5. Here in base system 21, it is 7. 7 means what will be the equation? X is less than n by 7, x is less than n by 7 square, n by 7 cube, and so on up to infinite. If I solve that equation, I will get n is greater than 6. N is greater than 6. 6 into 20 is 120. N is greater than 120. What is the multiple of 7 greater than 120? 126. 7 18s are 7 2s are. 18 plus 2 is 20. So in base system 10, I took the multiples of 5 and remaining all 5 values. Here multiple of 7. 126, 127 and so on up to 132. I hope the idea is clear. I hope the idea is clear. One more question which we will solve. Please write down, sir. Please write down. N factorial. N factorial. I hope the idea is clear. It is in base system 14. It is in base system 14. Right, actually it is 1,4, but I am calling it as an 14 because I will eventually convert into base system 10. 14 is nothing but 2 into 7. Highest is 7. So it is nothing but n is greater than 6x. N is greater than 120. So this is nothing but, if I take it as 15 zeros, if I take it as 15 zeros, let me take a different value. If I take it as 15 zeros, so this will become n is greater than 90. What is the multiple of 7 just greater than 90? So it is 7 13s are 91, 7 1s are 7, 13 plus 1 is 14 I got, but I want 15. What is the next multiple of 7? Which is 98. 7 14s are, 7 2s are. 14 plus 2, 16. I got 14 here, I got 16 here. Why? Because 98 is 49 into 2. There is a direct jump from 14 to 16. 15 will not be possible. No value of n exists. No value of n exists. I hope the idea is clear. No value of n exists. What I am doing? 20 is replaced by 15. 21 is replaced by 14. 14 is 2 into 7. 2 into 5 means n greater than 4x. It is n greater than 6x. N greater than 6 into 15, 90. N greater than 90. What is the multiple of 7 greater than 90? 91. 7 13s are, 7 1s are. 13 plus 1 is 14. Next, for what is the next multiple of 7? 98. 14 plus 2, 16. 14 became 16. 15 is not possible. No value of n exists. No value of n exists. I hope the idea is clear in base system other ones. Now let us solve one question that we did not solve. What is this question? Find the number of trailing zeros for 2016 factorial. 2016, if I divide by 5, 5 403s are, remainder 1, 5 80s are, 5 16s are, 5 3s are, 5 3s are. Similarly for 1008, 1008 it will be 5 201s are, 5 40s are, 5 8s are, and it is 5 1s are. 5 1s are. So 2016 factorial, how many I will get? These nothing but 80 plus 16, 96 and 99. 96, 99, 502. So this is 5 power 502 into K1, remaining all prime numbers, divided by 1008 factorial whole square. So these nothing but, how much I will get? 241, 250. 250. So these nothing but, this is nothing but 2 power 250. Please check the calculation. 16, 19, 99, 502. That is clear. 949, 50 into 2 whole square. Sorry, it is 2, not 2, it is 5 power. It is 5 power 250 whole square. So these are nothing but 252s are 500. So answer is nothing but 5 square. Number of zeros at the end for this expansion is 2. I hope it is clear. First I did it for 2016. 5 403s are, 5 80s are, 5 16s are, 5 3s are. 96, 99. So which is 502. 5 power 502. 1080 is 201. 540s are, 58s are, 51s are. 49, 50. 5 power 250 into K2 whole square. 252s are 500. Answer is 5 square. Answer is 5 square. Answer is 5 square. I hope it is clear. I made a small mistake. Instead of 5 power 250, I took it as 2 power 250. Please make a note of it. Idea is clear now. Idea is clear, right? Now we will solve few more questions. Still here, is it clear to you? Kindly reply in the live chat if till now trailing zeros. Foundation problems and exercise problems. Foundation problems and exercise problems. Is it clear to you? Kindly reply it in the live chat. Kindly reply it in the live chat if everything is clear to you. Kindly reply. Reply it in the live chat. Reply in the live chat if everything is clear to you. Right? Ambika, sir, why 150 factorial plus 2 factorial? We take common. No, we cannot take common. It is plus sign, Ambika, here. 150 factorial plus 200 factorial. If I take common, these 150 factorial, these 1 plus 200 into 199 and so on. This is divisible by 5. Any number divisible by 5 plus 1, that will be not in factorial, that will be 5k plus 1. Any 5k plus 1, any number which is of the form 5k plus 1, 5k plus 1, it is not factorial, Ambika. It is just a natural number. 6 is 5 into 1 plus 1. It will not have any power of 5. 11 is 5 into 2 plus 1. It will not have any power. I hope, Ambika, it is clear to you. Find the number of trailing zeros. Now we will solve some more questions. Some more questions. 1 minute, sir. Now please solve these questions. Then slowly the same model which we discussed. Number of zeros which are not possible at the end. Do it with one example, you will understand. If I take option 1, n is greater than 4x, n greater than 76. 76 is, next multiple is 5. 5 16s are 80. 5 3s are 15. 19 is possible. Option 2. Option 2. It is 28. N is greater than 4x. N is greater than 4x, which is 112. What is the multiple of 5 greater than 112? 115. So it is 5 23s are, and it is 5 4s are. 23 plus 4 is 27. Next multiple, 5 24s are, and 5 4s are. 24 plus 4 is 28. This is possible. Option 2 is also possible. Option 3. N is greater than 4x. N is greater than 144. What is the multiple of 5 greater than 144? 5 29s are. 5 5s are. 5 1s are. 35. Next it is 150. 150 is 5 30s are. 5 6s are. 5 1s are. 37. Directly from 35 to 37 there will be a jump. Why? Because 150 is 25 into 6. So 36 is not possible. That means if you check it out, 47 it is possible. 47 it is possible. I hope the idea is clear. 5 16s are, 5 3s are. Right, 16 plus 3 19. First option is possible. Second option 28 is also possible. Third option it is not possible. So answer for this question is 47. I hope this is clear. Trailing zeros advanced level. Next one. If n factorial, already we did it, n factorial ends with 30 trailing zeros, n is greater than 120, so these 5 25s are, 5 5s are, 5 1s are, it is ending with 31 trailing zeros. So answer is no value of n exists, no value of n exists, satisfying this equation, no value of n exists. No value of n exists. I think I did 4 into 47. I never did 4 into 47. I did only 36. 36 I did not even get. I got 35 to 37. Right? 4 into 47. I did it for n greater than 4x. For 36 are 144. I did not do for 47, Balaji. I hope it is clear. Next one. Please solve this question. Which of the following can be the number of trailing zeros? Can be, not cannot be. Can be the number of trailing zeros at the end of any factorial. Option 1, it is 63. N is greater than 4 into 63. N is greater than 252. What is the multiple of 5 greater than 252? 255. 5 5s are, 5 1s are, 5 10s are, and 5 2s are. 61 plus 2, 63 can be. First one itself is giving you can be, right? 63. But there is an option all of this. Let us do for the second one. If it is 68, n is greater than 4 into 68. So these is greater than 272. What is the multiple of 5 greater than 272? 275. 5 55s are, 5 11s are, and 5 2s are. 66 plus 2, 68. These also possible, right? If 2 are possible, obviously the answer will be all of these, because there is no option A and B, or A, B, or C, or A, B, and D. I hope it is clear, right? Very, very important learning for today. N is greater than 4x. Very, very important learning. N is greater than 4x. N is greater than 4x. Idea clear, right? Next one. Which of the following cannot be? This is, please solve it on your own. All the same examples we did it. Solve it on your own. What is the condition that needs to be used? N is greater than 4x. N is greater than 4x. I hope the idea is clear. Next one. Which of the following cannot be? Same concept. N is greater than 4x. N is greater than 4x. Now we will solve this question. Please see here. Read this question. Read this question. Till here it is clear. Till here it is clear. Now, all are very, very good questions. Let us solve these questions. Now see here. Till here, kindly reply in the live chat if everything is clear to you. Kindly reply in the live chat if everything is clear to you. N factorial has 2 more trailing zeros than n minus 1 factorial. How many 3-digit values n can take? How many 3-digit values? Till now, any doubts are there? Kindly reply it in the live chat. Any doubts are there till now before I solve this problem? Before I solve this problem, any doubts are there? Kindly reply it in the live chat. Then I will start with advanced level questions in trailing zeros. Advanced level questions in trailing zeros. Kindly reply. Shall I start with this question? I want each and every viewer to kindly reply in the live chat if these concepts are clear. Balaji says clear. Other students kindly reply. Other students kindly reply. Other students kindly reply. Shall we go ahead with this question? Question is, n factorial has two more trailing zeros. N factorial has two more trailing zeros. Two more trailing zeros than n minus 1 factorial. Two more trailing zeros. Two more trailing zeros means definitely I can say trailing zeros is formed because of the highest power of 2. So that means it is showing that it is an indication of 5 square into k. Two more trailing zeros. I hope it is clear, right? Two more trailing zeros. Trailing zeros happens in factorial for power of 10. In 10, it is 2 into 5. Power of 10 will take the lowest power of 2 and 5, which is nothing but the 5. Just by looking at the question itself, I am able to say that the answer is in the multiple of 25. Now let me take, if n value is 25, lowest one, this is 25 minus 1, 24 factorial. This is 25 factorial. Let us see what is happening. 25 has got 5 5s are 25, 5 1s are 5. 5 plus 1 is 6 zeros. 24 has got 5 4s are 20, 4 zeros. 6 zeros and 4 zeros. 6 zeros and 4 zeros. How many more trailing zeros are there? 2 more trailing zeros are there. 2 more trailing zeros are there. So that means n should take multiple of 25. First write down that point. N should take multiple of 25. I hope this concept is clear. N should take multiple of 25. N should take multiple of 25. That is clear, right? Now, multiple of 25. How many 3-digit values can it take? How many 3-digit values can it take? Listen carefully. Advanced level questions, beautiful questions. Beautiful questions. Now I will write down n factorial has 2 more trailing zeros than n minus 1 factorial means n will take multiple of 25. N will take a multiple of 25. That is the first conclusion. N will take multiple of 25. What is the 3-digit numbers? 3-digit numbers. How many 3-digit numbers I will get? What is the lowest multiple of 25? 25 4s are 100. 25 5s are 125. 25 6s are 150. And so on up to 1000 divided by 25 is 40. So which is 25 into 39. 25 9s are 225, which is nothing but 975. I cannot take 1000 because it's a 3-digit number. 25 4s are, 25 5s are, 25 6s are till 25 39s are. Step number 1. From 4 to 39, totally 36 values are there. Total 36 values are there. 36 values are there. In these 36 values, I need to subtract the numbers which are multiples of 5. Because if I multiply with 5, power of 5 will rise. If the power of 5 rises, then it will not have 2 more trailing zeros. That means 25 into 5 is out. 25 into 10 is out. 25 into 15 is out. Till here, 25 into 35 is out. Why? Because every time it is getting multiplied by one more multiple of 5, which will result in extra 5. I want exactly 2 more trailing zeros. I want exactly 2 more trailing zeros. So 5 ones are, 5 twos are, 5 sevens are. 7 values will not satisfy. So 36 minus 7. How many 3-digit numbers values n can take? Answer is 29. Very, very good question. Again I am explaining you. N factorial has 2 more trailing zeros. 2 more trailing zeros will happen with extra 2 more powers of 5. 2 more powers of 5 is n should be a multiple of 25. I hope it is clear. N should be a multiple of 25. I want 3-digit numbers. So 25 fours are, 25 fives are, 25 39s are. How many multiples of 25 are there from 4 to 39? Totally 36 values are there. Totally 36 values are there. In that values, I should not take these values. 25 5s are, 25 10s are. Why should we not take? If I take n is 125. 125 minus 1 is 124. And this is 125. Just check. 124 is 5 24s are 120. 5 4s are 24 plus 4. It is 28. 125 is 5 25s are, 5 5s are, 5 1s are. It is 31. 28 is becoming 31. Extra 3 zeros I am getting. But I want 2 zeros. That's exactly the reason I should. 25 5s are 25. All these are eliminated, which are 5 multiples of 25. 5 from 5 to 35, 7 values are there. 7 values are subtracted from 36. Answer is 29. Answer is 29. I hope the idea is clear. From 36, 7 are subtracted. Answer is 29. I will do one more question. Please see here. Please see here. If n plus 1, once you understand it is easy, sir. N plus 1 solution. N plus 1 factorial has 3 more trailing zeros than n factorial. 3 more means I should get a multiple of 125. Answer should be a 125 multiples. I hope it is clear. Answer is a 125 multiples. Why it should be a 125 multiples? Let us see. If this is 125 factorial, 5 25s are, 5 5s are, 5 1s are, 25 plus 5 plus 1, which is 31. 125 plus 1, 126, which will be 5 25s are, 5 5s are, 25 plus 1. Am I right? So 125, 5 25s are, 5 5s are, 1 minute. 5 25s are, 5 5s are, 5 1s are. If I do 1 plus n plus 1 factorial, n plus 1 is 125 multiples. So 125 plus 1 is 126. 126 it is 5 5s are, and 5 1s are. 5 1s are. 25 plus 5 plus 1, which is nothing but 31. Here we got 31, here we got 31. So what we'll do is, now that is exactly the reason n cannot be 125. N I will take 124. N I will take 124. If I take 124, this is 125 factorial. Now it should be clear to you. So 24 means 5 24s are 120. 5 4s are 24 plus 4, 28. Here it will be 125. 5 25s are, 5 5s are, 5 1s are, 31. That means very, very important concept. What is the previous question? Previous question is n and n minus 1. Here n and n plus 1. So n cannot take 125. The conclusion for this question is n plus 1 should be a multiple of 125. I hope the idea is clear. N plus 1 should be a multiple of 125. N is not a multiple of 125. If n plus 1 is a multiple of 125, n will be 124. 125 I got total 31. 124 I got total 28. 31 and 28 difference is 3. I hope it is clear. So please write down that point. Previous question n and n minus 1. Now it is n and n plus 1. So that means conclusion, solution, n plus 1 should be a multiple of 125. n plus 1 should be a multiple of 125. Should be a multiple of 125. How many 3-digit values n can take? 3-digit values. This can be 125 into 1, 125 into 2, 125 into 5, and 125 into 8. You can also take 125 into 8. Why? Because if n plus 1 is taking 1000, n value will become 999. 999 is a 3-digit number n can take. 125 1, 125 2, 125. Total here I got 8 values. Step number 2. I should eliminate the multiples of 5. 125 into 5. If I take 125 into 5, extra 5 is coming. This one value is eliminated. 8 minus 1 is totally 7 values. Please ask me any doubt in case if you have. N plus 1 should be a multiple of 125. I hope this idea is clear. N plus 1 should be a multiple of 125. So it is 125 1s are, 125 2s are, 125 8s are. N plus 1 is 1000. N value will be 999. Question is, how many 3-digit values n can take? N can take 999. Here n plus 1 is taking a multiple of 125. 125 1s are, 125 8s are. Total 8 values I will get, out of which one value, which is the 5 multiple of 125, that should be eliminated. Why? Because if n plus 1 is 625, n value will become 624. Just check it out. 624. 5 how many times? 5 12s are 60. 5 4s are. Again it is 5 2s are 20. 5 4s are. 5 4s are 28. I will get 152 here. 152. Am I right? For n plus 1, 624 plus 1, 625. 5 125s are. 5 25s are. 5 5s are. 5 1s are. How much I am getting? 125, 150, 156. 4 zeros I am getting. 4 zeros I am getting at the end. I hope the idea is clear. Kindly reply it in the live chat if this concept is clear to you. Advanced level questions. 3 more trailing zeros. 3 more trailing zeros. 3 more trailing zeros means n plus 1 should be a multiple of 125. N plus 1 should be a multiple of 125. 125 1s are till 125 8s are. N plus 1 is 1000. N will become 999, which is a 3-digit number. Eliminate the multiples of 5. Eliminate the multiples of 5. Ram, we are eliminating multiples of 5. If I multiply with another 5, one more 5 will come. 1 more 5 means it will not become 3 more trailing zeros. It will become 4 more trailing zeros. But I want the answer as 3 more trailing zeros. I want the answer as 3 more trailing zeros. So answer is 8 minus 1, 7 values. I hope it is clear. I will do one more question. Please write down, sir. N factorial has 4 more trailing zeros than n minus 1 factorial. How many 3-digit values n can take? Solution. 4 more trailing zeros. That means it should be a multiple of 5 power 4. 5 power 4 is 25 square, which is nothing but 625. Answer should be a multiple of 625. Right? So, what is the value? If n is 625, n minus 1 is 624 factorial. Next number will become 625 into 2 is 1250 factorial and 1249 factorial. This is not possible because I want a 3-digit value. Answer for this question is 1. If I replace the question as n factorial has 4 more trailing zeros than n minus 1 factorial. I hope the idea is clear. Very, very good high quality questions. High quality questions. Listening to the class once when the class is live, you might not understand it. Watch the class again and again. And the best way to watch the class is to buy a course. Quality problems are there in our course. I hope it is clear. Next one. Now, let us solve this question. n plus 3 factorial has 3 more trailing zeros than n factorial. 3 more trailing zeros. Answer should be a multiple of 125. Answer should be a multiple of 125. That means if this is 125 factorial, this will become 128 factorial. Now, what will be the let us check with the lowest value whether it is satisfying. These is nothing but 525s are. This is 5 are and it is 5 ones are. This is 31. 125 will be 525s are 125. 125 is 25 1. Again it is n plus 3. So the mistake which we did it is we are giving it to n. We should give it to n plus 3. We should give it to n plus 3. I hope the idea is clear. Good that I did this so that you will not do that mistake. So this is nothing but n plus 3 should be taking 125. So this is 125 factorial and this will become 122 factorial. Now you will get the answer. These are nothing but 525s are, 5 5s are, 5 1s are. Total I got 31. If it is 122, how much I will get? 5 24s are, 5 4s are. So I got 28 here. 28 and 31. There are 3 extra zeros that is present. That means n plus 3. How many values it can take? It can take, n plus 3 can take 1 minute, sir. N plus 3 can take n plus 3 can take previous question. Where are we? This is the question that we are solving. N plus 3 can take. What are all the multiples of 125? 125 it can take, 250 it can take, 375 it can take, 500 it can take, 625 it cannot take, 750 it can take, 875 it can take. So 1000 also it can take. So 1, 2, 3, 4, 5, 6, 7. So how many values n can take? Total 7 values n can take. I hope the idea is clear. I hope the idea is clear. Now we will solve 2 more questions, we will understand this concept thoroughly. I hope this idea is clear. These also we solved. These also we solved. This is we solved. Done, 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 done. Now, please see this question. Please see this question. Extremely important question. Very, very important question. Very, very, very important question. There will be a beautiful conclusion that will come from this question. Please read the question. Question is, M is product of all even numbers from 1 to 25, which is 2 1s are, 2 2s are, 2 3s are, 2 4s are, 2 5s are, 2 6s are, 2 7s are, 2 8s are, 2 9s are, 2 10s are, 2 11s are, 2 12s are. There is a reason why I am writing like this. So 2 1s are, 2 2s are, 2 12s are. It is 2 power 12 into 12 factorial. 12, what is the highest power of 2? 2 6s are, 2 3s are, 2 1s are. 6 plus 3 plus 1, it is 10. So it is 2 power 12 into 2 power 10 into 5 square into k, which is nothing but 2 power 22 into 5 square into k. I will write it like this. M is nothing but, as a power of prime basis, is 2 power 22 into 5 square into k. Am I right? 2 power 22 into 5 square into k. This is the M value. N we will do it, then we will do M into N has given how many zeros at the end. The value of M is 2 power 22 into 5 power 2 into k. Now, we will write it here. M is nothing but 2 power 22 into 5 power 2 into k. This is M. Now, N. N is product of all odd numbers from 26 to 200. Odd numbers will not be divisible by 2 because I require number of zeros at the end. Number of zeros at the end is 10, which is 2 into 5. 2 anyway will not come. So only take odd multiples of 5. Only take odd multiples of 5. Only take odd multiples of 5 from 26 to 200. Only take odd multiples of 5 from 26 to 200. What are all the odd multiples? 30 cannot be taken. 35 can be taken. 40 cannot be taken. So it is 45, 55, 65, 75, 85, 95, 105. You might miss out some values, so I am writing it like this. 115 into 125 into 135 into 145 into 155 into 165, 175, 185 and 195. I hope it is clear. So this is N equivalent to, listen carefully sir here. Listen carefully, otherwise you might do a mistake. Why we have taken only multiples of 5? Because I want zeros at the end. Zeros at the end is 2 into 5. Zeros at the end is 2 into 5. Right? I hope it is clear. Now see here. I will get one multiple of 5. 5 7s are, 5 9s are, 5 11s are, 5 13s are, 25 3s are plus 2. 5 17s are, 5 19s are, 5 21s are, 5 23s are. 125 is plus 3. This is 5 into 27 plus 1, 5 into 29, 5 into 31, 5 into 33, 25 into 7 plus 2, 5 into 37 plus 1, 5 into 39. These are all extra highest powers of 5 which we got. So what is that powers of 5 we got? N is nothing but 1, 2, 3, 4, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 19, 20, 21. So this is nothing but 5 power 21 into K2. So if I do m into n, which is nothing but 2 power 22 into 5 power 23 into K3. This is nothing but 2 into 5 power 22 into 5 power 1 into K3. Answer for this question is 22. Answer for this question is 22. A very beautiful question which tells you that number of zeros at the end is not always highest power of 5. Depending upon the question, it can be highest power of 2 also. M is 2 power 22 into 5 power 2 into K. N is odd multiples of from 26 to 200. Odd multiples. So 2 anyway will not be there. You don't need to write 27, 28, 29 because I want number of zeros at the end. Number of zeros at the end is highest power of 5. Take only the odd multiples of 5. 35, 45, 55, 65, 75, 85, 95, 105. Till 195. Check how many multiples of 5 are there. 5 7s are, 5 9s are, 5 11s are, 5 13s are, 5 15s are, and 5 13s are. Why we wrote plus 2 here? It is 25 into 3. Here it is 5 cube, it is plus 3. Here it is 25 into 7. 1, 2, 3, 5, 6, like that if I add, I got 5 power 21 into K2. Very, very good question which proves that number of zeros at the end is highest power of 5 only for factorial. If the question changes, it could be the highest power of 2 also. If the question changes, it could be the highest power of 2 also. Please see this question, analyze this question. Any doubts are there, please ask me. Any doubts are there, please ask me. I hope this is clear to you. Kindly ask me in case if you got any doubts. Kindly ask me in case if you got any doubts. Very, very good question which helps you to analyze. Is this clear? Is this clear? Right? 1000 we can take in the previous question because 1000 is given to n plus 3 or n plus 1. N is not taking that value. N plus 1, n plus 3 is taking that value. Idea is clear. Everybody kindly reply to this one if the idea is clear to you. Mahesh, I hope you got the doubt. Sai, I hope you have understood why am I not doing 125 into 5. Everybody, is it clear to you? Very, very good question. Please analyze this question after the class. Number of zeros at the end is not always the highest power of 5. It could be the highest power of 2. Kindly reply in the live chat yes if it is clear to you. If it is clear to you, kindly reply it in the live chat. Idea is clear? Now till now, what are the topics that we did it? Still in the evening, we have got a lot of good questions to solve. Yesterday we did all these questions and now we did highest number of zeros at the end, trailing zeros. Base system we did it. Number of trailing zeros for n is highest power of 5. Number of trailing zeros if 2 factorials are added, if 10 power is given, right? If factorials are divided, if only the number of trailing zeros are given, how to find out the value of n? And in base system, how to find out the value of n? Now in the evening, we are going to do some other extraordinary questions to you, sir. Some other extraordinary questions to you, right? I hope the idea is very, very clear to you.